Welcome. This is going to be our video for your first Mastercam programming assignment, at least the first project assignment that you're going to use Mastercam to program for. So this is going to be our Vise stop print or our Vise jaw stop print. We only have a PDF for this, so I'm actually going to draw this just as geometry. If you want to make a solid, feel free to make a solid and utilize a solid to program this. If you want to do it a little different, that's fine with me. But there is no solid provided, so all we have is the print to go on. So without further ado, let's go ahead and get started. Okay, so we have a new file open in Mastercam. First thing I'm going to do is I'm going to go in and I'm going to grab my machine, VF2. Okay, and the next thing I'm going to do is I'm going to decide what stock I want to use. So I want to make sure I basically plan out how I'm going to make this part first. So looking at this, I don't want to match mill if I can possibly help it. It looks like it's almost a 1/2 inch thick. It's actually 7/16 thick, 1.25 inches by 3/4 inch. So if I have 1 inch material, and if I have maybe like 5/8 thick material, that's great. I can just cut it to a little bit over, maybe 1 3/8. So I'm going to assume that I have at least 5/8 material, or at least 3/4 material, but I'm going to assume that I have 5/8 material. You're going to want to go and check before you go and start programming. Make sure you have your material and you know exactly what material you're going to use. Otherwise, it's going to give you a bunch of headaches and you're going to have to go back and change a lot of things. So make sure you check your material before you do anything. All right, so we're going to assume 5/8 thick material. So I'm going to set my material up. I am going to right click, edit bounding box. We are going to make this out of 1.375 by 1 inch wide by 0.625 thick. And we are going to use the upper left corner for our 0, and I'm going to hit check. Actually, I changed my mind. We're going to use center for our location, and we're going to 0 these out. Yeah. So we're going to make this on center, and that is because we are going to be using the probes for this project. This is going to be the project that we start using the probes with. Okay, so we're going to go home, wireframe. I'm going to create a rectangle, 1.25, so it's already in there. So I'm just going to go ahead and click that rectangle, and I have anchor to center selected there. So there's the outside of my part. So I'm actually going to create some levels for this stuff. I'm going to call this one Perim Geo. So that's the perimeter. And then I'm going to create another one. And just looking at this, it looks like these are located at 320. I'm just getting an idea of where those are at. So we're going to create these lines, and we're going to create them at 0.320. Oh, I clicked out of here. Now I clicked in here, 0.320, comma, 0.375, and that's actually not where it's going to be because I don't have it. I have it centered now. So I'll tell you what I'm going to do. Rather than doing that, we're going to make it even easier. We're going to just offset some lines that we have. So we're going to go ahead, click on this line. We're going to offset it to this side, and we're going to offset it 0.320, and we are going to copy it. Check. Okay, going to do that again. Offset, and offset to this side, and we're going to offset this in 1.05, and we're going to copy it. Check. Okay, there's our lines. That's simple. I'm going to grab these, and I'm going to move these to level 2, and we're going to call that, and I'm not going to move them, I'm going to call it slot geo. Okay. All right. Now this isn't totally finished yet, so I'm going to turn off that perimeter geo. So I turned that off, work on my slot level. I'm actually going to draw some just random lines coming off of here at 90 degrees so I can use my chamfer command. And we're going to put a 10,000th chamfer on these corners. And I know I'm going through this pretty quick in the video, I'm under the assumption that people like quick videos, and you can always rewind and watch it again in that section if you missed something. So hopefully this is a little better than a long, drawn-out video. All right, so there's our slot geo. Lastly, actually, I'm going to wait to create the chamfer geo. So I'll wait to create that here, and I'll create that later. Okay, so we have these. So I'm going to turn all of these on, and we're going to start creating tool paths. So first off, we're going to face this thing. So I'm going to face like 10 thousandths off the top of this, just so I have a nice clean surface. So I'm going to hit face. I'm not going to select anything because your face is stock aware. So if I want to face the stock, I'm just going to not select anything. Going to go ahead and select my tool. I'm going to use a 1/2 inch end mill for everything here. Let me see here. I actually have one set up, so I can grab a 1/2 inch end mill. And as you can see, it's already set to 350. So I have a lot of this stuff set. 50 inches a minute for my plunge, because I'm not going to be plunging onto anything. 70% step over looks good. A long overlap going past. This stuff all looks good. This here, I can make this 20%. I change that. Now, the way these work is this across overlap. This actually is how much past the stock it's going to overlap. So as of right now, actually, why change this? I'll pick at 20%. So as of right now, 400 thousandths of my cutter is going to be on top of the stock cutting. 100 thousandths is going to be off of it, if that makes sense. So most of the cutter is going to be on top of the stock for that first pass. So across is how far across it's going to go in the y-axis in this case. Along is how far past it's going to go in the x-axis. So the whole cutter is going to come off of the part. And that's just a preference. It doesn't need to. It's just going to be the sort of finish that you want at the end of the day. So I'm going to go ahead and roll with that. Linking parameters. I'm going to face at 0. And when I touch off the top of my stock, I'm just going to offset my G54 down 10 thousandths. So then I'm facing at 0. That way I can program to all my depths on my print, instead of having to add 10 thousandths to every single depth that I'm going to do. Not that there are many, but it just makes things easier from my perspective. Okay, so let's go coolant. We're going to turn that on after, hit check. All right. There we go. So we have the facing path done. Next thing I'm going to do is going to mill this out. I'm going to pick a dynamic mill. My machining region, again, this is my stock. I want to machine away the stock. That's my region. And I want to start from the outside and work my way in. What do I want to avoid? Well, I want to avoid my part. So I'm going to select the outside. Oh, I have single selected. So I'll unselect that. And I'll select the whole perimeter there. Now hit check. Check. Okay, I'm going to grab this tool again. Looks like I have everything set good there, 50%. That's the advantage of having tools preset. Most of this stuff's set. The plunge rate could be set too, something I overlooked when I made this tool. Cut parameters. Okay, so step over distance. We're going to go 20% on that. Stock to leave on walls. We are actually going to leave a little bit of stock on walls. We're going to run our own contour pass for the finish, rather than using the new finish pass in Dynamic Mill. They still have some things they need to add to this. So this is new in 2024. They actually can run a finish pass in Dynamic Mill. The problem is they don't have the roll around corners option, which is really unfortunate. Hopefully they add that in here at some point. That would be great. So we're not going to use this. All right, depth. So it looks like our depth, this thickness of this thing is 338 or 438. I am going to assume, well, first off, if I have 5/8 stock, I'm holding on to an 1/8 in my vise, which leaves me it actually leaves me a little bit more than a 1/2 inch sticking above my vise jaws. Technically the vise jaws are 1.73, so I actually have 520 thousandths sticking above my vise jaws, because my parallels would be 1 5/8. So I already faced 10 off, so that leaves me 510 thousandths sitting above my jaws. I'm going to assume that I have a 30 thousandths tool nose radius or a corner radius on this end mill. So I need to go down at least an extra 30 thousandths. So that's going to take me to basically 480. So that's where I'm going to go to. And maybe I'll just go to 485. So I'll go to negative 0.485. Top of stock is 0. That's good. Entry motion should be plunge. Tolerance 1,000. That's fine because we're just roughing. Coolant. We're going to turn that on after. Check. Okay. So there's our roughing pass. I just want to check one thing here. I'm going to change this to never. Check. There we go. All right. That made it a little more efficient. Okay. Next thing I want to do is I want to finish this. So I'm going to grab it with a contour. Grab the same tool again. Change this to 50 inches a minute. Let's see here. We're going to go into our cut parameters. Here is what I was talking about. This does not exist in the finish pass for dynamic mill. It does in the contour. So this is a huge advantage. And I'm gonna leave it 0 now, and then I'll show you what it does. So I'm gonna go ahead and click down 10. That's good. We have a little bit of overlap for a lead in. That's good. Depth, again, this is going to be negative 0.485. Arc filter, this we want turned down. You can see I already have it defaulted to a lower amount. So we're going to hit on, after, check. All right, so that created our finish pass. So let's take a look at this. And let's just simulate and see what we got here. All right, so if you look at this, you can see that there is a sharp corner on there. It doesn't make sense to just machine sharp corners, right? We have the ability here to round those over. So let's do that. And we don't actually even need to change our geometry. That's what this roll around corners does. So if I go back into my cut parameters and I say external corner break radius 0.01, we're going to put a 10,000th radius on all external corners. And that's just something that it does for us automatically now. We don't even have to change our radius. So that's a pretty awesome feature. Now, what we can do next is we can do our slot here. So to do our slot, I'm going to use a peel mill. Okay. I'm going to grab this one. And I'm going to grab this one, hit check. Grab my 1/2 inch tool. Turn on my radial chip thing. Turn up my plunge rate to 50 inches a minute. My step over distance is going to drop that down to 20 again, just like the other one. Okay, I'm going to reduce this as much as I can. I'm going to put 0.1 in there. Okay, so 2.5. It default to the smallest, so let's put a ridiculously, absurdly small number, and it'll just default to whatever the smallest it can be is. The reason I'm doing that is because it's a 730 wide slot, and we're using a 1/2 inch end mill, so you want to keep that radius as small as possible, otherwise it won't write the path for you. Finish passes, we're going to make that 0.005, and I'm going to do a spring pass because this is plus or minus 2 thousandths here. So we're going to do one spring pass. I'm going to make sure wear is on. The depth of this is negative 0.24, and all this stuff looks good. Arc tolerance 0.0001 looks good. Coolant on, after, check. And there is our path. All right, so let's take a look at that. Around there. Sweet. We got our chamfers, everything there looks good. All right, last thing we need to do on this side is we need to chamfer all the edges. We need to chamfer these top edges. We need to chamfer this bottom edge here. Everything should be chamfered. Babies should be able to play with this and not cut themselves. Probably a choking hazard, though. So I don't recommend letting babies play with it. All right, so to do this, first thing I'm going to do, I've got a lot going on here. I'm going to turn off all these tool paths so I don't have to look at them. I'm going to create special geometry for this. So I'm going to take this and I'm going to copy it. And I'm actually going to copy this to level 3, and I'm going to call it chamfer geo. Whoops, don't need an H in geo. Check. Darn it. I accidentally moved it. Okay, so you can see I moved it. I'm going to undo that. I'm going to redo it again. And I'm going to move it to 3, chamfer G. I'm going to copy it this time. Okay, so now we have all that geometry. I'm going to make sure I'm working on that level. I actually have exactly the geometry that I want. The only thing that I really don't want is I don't want this line to be all one. I actually want it to be broken here and here. I could break that, but I'm actually just going to divide it. I'm going to add it back in. I find that actually easier in a lot of cases. And while I have it broken there, I'm actually just going to go ahead. I'm going to add these radii on so that way the chamfer follows the radii correctly. All right. So I'm going to go ahead and create my chamfer path for those top pads now. And then I'll redraw those lines in and I'll create the chamfer path for the bottom one. All right, so let's go ahead, contour, select this one and this one, check. All right, I'm going to grab my tool and we're going to go ahead and grab a 1/4 inch chamfer mill. It says the selected is not defined, capable of both roughing and finishing. Okay, for some reason it thinks we're going to rough with this. Probably because multi-passes is on. So if you get that alarm, it's because this is on. You just want to turn that off, and you'll be good to go. All right, so 350. You can tell I don't have this tool set up correctly. And plunge rate, we'll make that 20 inches a minute. Because we're going to come off of the part again. We're going to lead in for this. All right, so I could probably go a little faster than that, but we'll just leave it. Actually, I'll just make it 25 even there. So whatever that works out to, feet per tooth. All right, cut parameters. We're going to go into 2D chamfer. And our chamfer width in this case is 0.01. And bottom offset, we'll make that 50 thousandths, 0.05. And I'm going to take this off because I added those corners in now. So I added those radii in for this geometry. Lead in, lead out. That looks good. Linking parameters. I definitely don't want to be there. I want to be exactly at wherever my geometry is at for this. This part here will take care of your depth. So wherever the geometry is selected, if it's at negative 0.48, then I do want that in there. If it's at 0, then I want 0 in there. So this should always be wherever the geometry is at. And I can change it to absolute. It doesn't matter what it is if it's 0. That's good. Coolant. On, after. That looks good. Okay. There's our chamfer paths. All right. Lastly, I'm going to add these lines. The only reason I'm adding it in after is just because it makes selecting those other profiles a lot easier if they're just not, these lines aren't there, because it reaches a branch point and you have to tell it where to go. So let's go to tool paths, select this again. I'm going to do 2 single lines this time. I'm going to start over here so that I'm climb milling, and over here so I'm climb milling. Okay, we're going to grab our tool again. Oops, 350. Oops, 350. And we'll make this 25.0. We'll make this 20.0. We'll use our 2D chamfer, 10,000th. Okay, that all looks good. Lead in, lead out's fine. Linking parameters. All right, now technically this profile is negative 240 deep, right? That's where the corner is that we want to chamfer. So I do need to offset this down because my geometry is up at 0. So I need to say this is at negative 0.24. Okay. And on after. Okay. All right, so let's take a look at this. And this is not going to look right at first, but I just want to show you an important thing here. Okay, so all that looks good so far. All right, so everything looks good there, including these chamfers here. Right here we have a little bit of a gouge. So we got to watch out for that. All right, so first things first. If I come out of here, and let me go into the right-handed view, and let's take a look at just that tool path. Oh, I just see one other thing. This flat is not actually on my tool. you want your chamfer mill to represent what your tool looks like. So the first thing I'm going to do is I'm going to change this chamfer mill. It's a 60 thousandths flat. I'm going to say 0.001 because our chamfer mills are pretty sharp. There's really not a flat on them. I'm going to go ahead and hit finish, check. That's going to update everyone that's using that tool. And then I'm going to grab this again, and I'm going to come in, and I'm going to take a look here. Okay. This actually isn't the best way to do it. Let me do it in simulation here. I'm going to have to do the whole thing. So let me fast forward through some. That one, okay. I'm gonna zoom out. Looks like it's coming in over here. So let me go to the right-hand view. Okay. So you can see where it's actually doing the chamfering here. It's chamfering down at this diameter. I'm never going to be able to get very close to that corner with this if I'm chamfering with the lower part of the tool. I want to be chamfering with the highest part of the tool as I can, so I can get into that corner as close as I can. So what I'm going to do for this is I'm going to change from my bottom offset to a top offset, and I'm going to offset at 0.005. I feel like that's a comfortable amount. I could go less if I wanted to, but 5 thousandths gives me a little bit of leeway there. All right. So that's done. Now the next thing I need to do is, this is still going to gouge my part. So I need to adjust my contour. I need to shorten it. And I'm going to start by shortening it 30% of the cutter. Let's see what we get. Okay. Oh, wow. That actually worked. So we're pretty darn close. I think we can actually get a little closer here. So to do that, what I'm going to do is turn this other one off. Alt-T. And I'm going to grab this one. And we're going to reduce that a little bit. So we're going to make that 28% of the cutter. And I'm going to come down with this cutter. I'm going to have a top view. I just want to make sure this cutter doesn't break this line here, my chamfer there, that edge. I'm going to step through. I can probably actually go a little closer. Let's do 26% of the cutter. Let's see what we get. That's pretty close. I might be able to go a little closer, but I'm happy with that. I can deal there. All right, so let's take a look and see what we got. That is pretty darn good. That's almost completely deburred. You're really not even going to be able to get your finger in there to cut yourself on something like that, because it's just in between those two edges. So that looks great. That is side one complete. Okay, now we need to do side one, or side two. So first thing I'm going to do is I'm going to rename this Op 1. You can call it top, whatever works for you. And I'm going to create another group. Notice I clicked on the machine group. You want to click on the machine group because you want it to be under the machine group, not another operation under your Op 1. I can demonstrate that by saying new toolpath group. Notice, see how it comes way down right off the machine group? If I were to do it on here, it comes down underneath here. So it's inside of Op 1. You don't want that. That's not ideal. Oh, I do not want to delete those. I just want to delete this. I almost deleted all my toolpaths. Okay. The next thing I'm going to do is I'm going to select Op 1. I'm going to right click. I'm going to edit selected operations, and I'm going to change the NC file name, and I'm going to call this Op 1 top. And you may want to call it like Vise stop Op 1 top. then it'll actually name your NC file that when you post it. So that's how you change the name of your NC file. So we're going to go ahead and hit check. Okay, I'm going to call this op to bottom. Okay, and I'm going to bring my arrow down there, down below it. Okay, so now I need to, basically what I need to do here is I need to flip this over and I need to machine the extra material off the top of it. I need to chamfer around it, and then I need to, that's it. Actually, I need to engrave my initials in it. So I need to engrave my initials in it as well. All right, so what I'm going to do is I'm going to turn off all of this stuff, and I'm going to create another, basically what I'm going to do is I'm going to create another work plane here. So I'm going to go to planes, and I'm going to click on my planes, and I'm just going to create another one relative to top, and I'm going to call this op to bottom. I'm going to hit check. Okay. Now, I'm going to right click on this and I'm going to edit it. So as you can see, it's not exactly oriented the way that I want it to be oriented. So I'm going to hit top real quick just to make sure I'm looking at it correctly. All right, what I really want to do is I want to rotate this around 180 degrees. Whoops, not that. I accidentally escaped. I want to rotate that around. So I'm going to grab that little radius and I'm going to go 180 point, enter. And I'm going to hit no. Okay, I don't want to associate it with new geometry. Okay, now I'm on the bottom of my workpiece. So now if I look at this from the top, if I hit top, whoops, I gotta work on this first, equals, and then I hit top. What the heck? Hold on. Oh, that got skewed somehow. All right, let's delete that, because that got twisted somehow. That wasn't supposed to be like that. All right, so let's hit equals. We'll delete this one. Selected. And we'll create a new one. Relativity WCS top. Call this op to bottom. Check. All right. Now I'm going to right click on this, edit. And we're going to rotate it around the X. 180 point. I'm just going to hit yes. It doesn't matter if you hit yes on that. Now I don't know why that is swinging that direction. Let me take a look at that again. Let me delete that. Selected. This is top. Up to bottom. Check. Okay. Edit. Well, now that's weird. Now it's good. I must have been clicking on something and twisting it the wrong way just because I was in a weird view. Okay, so now we're good. So if we hit top, now it looks right. So now our WCS, our Z0 is on the bottom of the part. So what that means is when I put this thing on parallels, when I set my G54 or 55 or whatever you're using for this operation, I'm going to touch off, I'm going to probe the bottom of the vise, and I'm going to offset up the thickness of my parallels or the height of my parallels. And that's going to put my 0 on the bottom. So all of my Z values are going to be positive at this point. What that's going to help me do is that's going to help me create the exact thickness of this part. So I don't have to worry about touching off the raw stock and then feathering it in. It's going to help me. I'm going to be coming off a machine surface, which is going to be the machine surface that we just made. Okay, so I'm going to go ahead and hit isometric. All right. Now, I need to face this away. So the first thing I'm going to do is I'm going to go to my toolpaths and I'm going to create a face path. So I'm going to get toolpaths, face, and I'm not going to select anything because I want to face away the stock. I'm going to select a tool, 1/2 inch end mill, 50 inches a minute for the plunge. Everything there looks good. Now, I have stock overhanging on all sides. If I zigzag this, when I get to the other side, a piece is going to go flinging off. So, to avoid doing that, I'm actually going to change this to dynamic so it works its way in from the outside to the center, and then I don't have to worry about this little overhung piece flying off and whipping against the side of the machine. My approach, step over distance, I'm going to make that 20%. And linking, that's good. Depth, well, my depth is going to be the thickness of my part, positive, right? Because my 0 is at the bottom of the part now. So that's 438.438, positive. Top of stock, well, I know that I have basically, if it was 5/8 stock, I only took 10 thousandths off of it. Essentially, it's 5/8. So I'm just going to put 0.625. If you want to put 615 in there, that's fine because that's really more accurately what it is. So then I'm going to make this 0.7 and I'll make this 0.75. So they're all above the stock there. So you can see now I'm looking pretty good there. Arc filter. Okay, this looks good. Now, if you want to use a different work offset for this, this is where you can change it. 0 would be G54, 1 is G55, 2 is G56, 3 is G, and so on. An easier way I'll show you here in a second. You would have to change those in every single toolpath that you create. Flood is on after, that looks good. Okay, so there is our face path. All right. Now, if you want it to automatically do this, you can right click on this and hit edit. And anything on this plane, we can make it go to G55 by putting a 1 in there and hitting check. And then it'll say, do you want to update the operations? Yes, we do. Now, if I go in here in the planes menu, it's going to have a 1 in there. So anything that I create on that plane will automatically be G55. Okay, so let's say I don't like that finish. I don't want that swirly finish. I want a nice back and forth finish. What I could do is I could just leave 10 thousandths on the floor. And then I could just take this path and I could copy it after. Go to my parameters. Take that 10 thousandths out. Turn this back to zigzag. Still has all my old parameters in there, so I like that. Step over, we'll make that 75 in this case. Linking parameters are all set correctly. That's why you paste it. Everything is set correctly. Check. So now if I look at this from the front, you can see there it's milling that 10 thousandths way, and I'll end up with that finish now. I won't have that swirly finish if I don't like that. If you like that, that's fine too. One note, if you choose this dynamic face, which you should, to get rid of that overlapping stock. If and when you choose that, if your end mill has a radius on it, a 30 thousandths corner radius, and your end mill doesn't in fact show that, oops, that ain't what I wanted. That ain't what I wanted. There we go. 0.03, finish. And I'm going to hit check, and it's just going to update everything based on that. But if it doesn't, notice where the start point went. It'll actually leave kind of a little cone sticking up in the middle of that part because it doesn't realize that there's a radius there. So if you tell it there's a radius, it'll actually machine everything away then. So you got to be careful of that. And there are radiuses and chamfers on almost all of our end mills. So you probably want to update that to a slight bull mill by putting the 30 thousandths radius or whatever's on your tool. All right, let's take a look and see what we got here. There we go. So that looks pretty good. All right. Next thing we need to do is we need to chamfer that. Okay, so what I'm going to do is I'm actually going to go and use my levels, and I'm actually going to turn off my chamfer geometry. I'm going to turn on my perimeter geometry because now I just want my perimeter. So I'm going to use that for my chamfer geometry now. So I'm going to go ahead and hit contour. Oop, I have single selected again. Pick contour, check. All right, tool, chamfer mill, 350. Make this 25 even. Make this 20. Cut parameters. I'm going to be down in the vise a good ways. So I'm actually going to do a bottom offset for this one because I don't need to get in close to anything. And if I have that, if I'm using the very edge of that tool, if it's only sticking out of the vise 1/8 of an inch, I'm going to get pretty close to hitting the tip in the top of my vise jaws. So I'm going to do a bottom offset of 50 thousandths for this. That should be fine. That means it's only going to go 50 thousandths past the top. Lead in, that looks good. I don't need this shortened thing here on anymore. Linking parameters, okay. Now, technically I selected the bottom. So where am I chamfering at? Technically I'm chamfering at the thickness of the part, which would be positive 438. So I need to put that in there, 0.438. It looks like all of these are pretty good here. So we should be in good shape. Technically the stock is 0.438 now because we just machined it away. Flea plane, we can make that 0.5. And this we can make 0.6. I'm going to go ahead and hit check. And that's going to create my chamfer path around the outside. Check. Oh, I tried to post it. I don't want to do that. Okay, play. Machined it away, and we've chamfered. Okay, take a look at the chamfers. Looks a little goofy there. Why is that? Well, because I picked the contour that's square, but I didn't put this 0.01 in here. Check. Now, let's take a look. These are the kind of details you want to make sure you're checking your simulation for. Much better. Now it's rolling around those corners. Okay. That looks good. I'm going to turn those off for a minute. I'm going to go to top. And I am actually going to create some letters here because you are supposed to engrave 0.3 initials in the center of the bottom face. So that would be this here. I guess we would technically, as you're using the stop, it would technically be the top. But the bottom face via the print. All right, so let's go ahead and take a look on wireframe, create letters. I'm going to say JAK. We are just going to draw, we're just going to use stick letters here. And I'm going to make them 0.3. And I'm not sure what that's creating. So what we'll use is Mastercam box. Let's see. We're going to choose some fonts here. Drafting stick. That could be better. Roman? No, can't you? Well, you can do that. I really don't care what you do, to be quite honest with you. You can do outlined if you want. Just make sure it's outlined big enough that it's going to engrave correctly. I think that's probably what I'm going to do. All right, so I'm going to go ahead and I'm just going to place this random spot, hit check. Then I'm going to select it, and I'm going to hit dynamic. And it's always going to give me this center point of it. And then I'm just going to grab that. I'm going to put it right in the middle. Check. And obviously it's at 0. That's fine. I'm going to go ahead to my toolpath, pick a contour. Oh, hold on a second here. Something I just noticed. My facing path is below that. I want to move after. Somehow my little arrow got put in the wrong position. There we go. That contour should be after this. Move after. All right. How about I move this in before? Well, that worked. Let me turn this on, just make sure it's the right one. Yeah, it is. Okay. All right, now we're good. So I'm going to go ahead and pick contour. And I'm going to select window. I'm just going to window that. Hit check. Tool. We're going to pick a 16th ball mill. So go into ball mill. Check. 16th. Spindle speed is going to be 12,000 for this for sure. Feed rate. We're going to feed this at about 6.0. We'll leave this at 6.02 because we're going to do a lot of plunging while we're doing this. We're going to turn our compensation off because we're going to do center line cuts with this. We're going to go back to 2D contour. Corner breaks, no, not on this. Lead in, lead outs need to come off. We don't want any lead in, lead outs. And depth. Okay, so our depth. Remember, it's positive from the bottom. I want to go 5,000 deep here, so I'm just going to subtract 5,000 from this, which is going to give me 0.433. So I'm going to be working at depth of 0.433 positive. This here is now going to be 0.4375 or 0.438, I guess. 5, 6, that looks good. Okay, that looks good. Planes, that looks good. Check. Okay, there's my engraving. All right, let's see what we've got. There we go. So, part fully engraved. We are in good shape. Next thing I'm going to do, I'm going to right click on this and I'm going to edit selected operations, change NC file name, op to bottom. Check. Now, when I go to post this code, I can select everything by grabbing my machine group, hit post, check, and I don't know where this is, I don't really care where it saves it, but right here's op1, so I'm going to save that. And now it's going to ask to save op2. I'm going to save that. And then when our NC editor comes up, it'll have both of those in there. I haven't transferred all of my settings over yet, so it still has Code Expert as my default here. So there's op1 and there's op2. Notice op2, you want to look through, right there's my G55, so I have that in there. So the only thing left to do is drill and tap these two holes in here. So I will leave that up to you to figure out on your own. I'm pretty sure you should be able to figure out how to tap these two holes. You can either do it in a new file, or you can also just create two tapped holes on your right side plane or left side plane, whichever you choose. In this case, I guess it'd actually be your left side plane. Yeah, they're going through here, so you'd be creating them on your left side plane looking down. And you can make that G56 if you'd like. Doesn't really matter. One note for setup. What you will need to do is when you set up your first op and you run your first op, it's going to machine around it and you're not going to be able to access or probe the part because you're going to have a carrier strip that's going to be all around it. You can't probe underneath that. So what you can do is you can probe, set your stop, put it in your vise, probe the carrier strip, set your G56 for that carrier strip, not the Z. The Z you set off the bottom of the vise and offset up the height of your parallels. But the XY, you can probe the carrier strip, set it, run the face program, run the facing part of the program, stop it after it's done facing, and then you can reprobe the part from there. Then you'll be probing off your machine surfaces and everything will be centered. Your chamfer should all line up perfectly. So Anyway, if there's any questions, you can always see me during my office hours. Hopefully this is very helpful in programming your first Mastercam project. From here on out, there won't be any videos, so hopefully this was helpful.